Too thin uh, too thin uniform ring made of wire of same material. This is same material, and radii r and 4r are joined as shown. The mass of a smaller is m, so this ring has mass m, and mass of this ring is not given, but what is asked, find the moment of inertia of the system about an axis passing through center of mass of bigger ring. About this, I mean, this is the axis about which we have to find the moment of inertia of the whole system. So the actually the longer this length, the mass will be more. So this is 2 pi r, and this is 2 pi into 4r, I mean 8 pi r. So this length is 4 times of this length, so its mass will be 4m. So we have got the mass of the bigger ring. Now we have to find the moment of inertia of this system about this axis. So we can I equal to I small ring plus I big. Now I want to make you remember that moment of inertia of a ring about its center of mass. This is ring, suppose, and this is its axis about which moment of inertia is to be calculated. It is I equal to m r square. This is the formula that we are going to use in this question. But this is moment of inertia about an axis passing through its center of mass, and axis is perpendicular to the plane of the ring. Now for I big axis is this one, and axis is passing through center of mass of the bigger. So I will be we have to put 4m instead of m, so we have 4m, and radius is 4r square. So this is 64 mr square. Now for I small, I mean moment of inertia of this ring about this axis. So I am going to use parallel axis theorem. This is the axis, and this is h equal to 4r and r 5r. So I am going to use ICM plus mh square. So about this axis, its moment of inertia will be mr square. So this is mr square plus m and 5r whole square. So this will be equal to 26 mr square. Now we have got the moment of inertia of smaller and bigger, we have to put here. So I equal to I moment of inertia of a smaller ring and moment of inertia of big about the same axis. So this equal to 26 mr square plus 64 mr square. So this will be equal to 90 mr square. So this is the correct answer. A person draw water from 5-meter deep well in a bucket of mass 2 kg of capacity 8 liter by a rope of mass 1 kg. What is the work done, total work done by the person? Take the value of this. So we have Suppose this is a well from where we have to take the water. Suppose this is the water level, and we have a bucket here, and this is the water in it, and this is the length of the rope. So this length is this is actually 5 meter long, and its center of mass is here. I mean, this rope has mass 1 kg, so this is 2.5 meter, and this is 2.5 meter, and this is 1 kg. So when I pull this rope up, I think this 1 kg mass goes up by 2.5 meter up, while this 2 kg bucket plus 8 kg water. How did I know that this is 8 kg water? Because this is 8 liter water, and 1 liter equal to 1 kg in case of water, because its density is so much. So total work done equal to this 8 kg will go up 5 meter up. So mgh for water, and plus mgh for rope, and mgh for bucket. So these two together is 10 kg, and they have to go up by 5 meters. So 10, take the value of g this, and this is 5, and in case of rope it is 1 kg, g is 10, and this is 2.5. so this will be equal to 500 joule plus, and this equal to 25 joule. Altogether it is 525 joule. So this is the answer. A ball of mass m hit a floor with speed v, making an angle 45 degree with the normal of the floor. If the coefficient of restitution is 1 upon root 2, find the angle of reflection. I want to tell you one thing without derivation, that if this is a surface and anything strike here and it collide, and this is normal to this point, and it reflect back like this, and if E is coefficient of restitution, one must remember that this is the angle of incident and this is angle of reflection. We have formula tan phi equals tan theta by E. In case of perfectly elastic collision, E equal to 1, in that case tan phi equals to tan theta. So phi equal to theta, angle of incident equal to angle of reflection. This happen in case of perfectly elastic collision. Now here theta is given 45 degree. Theta is 45 degree, and E is 1 by root 2. So tan phi equal to tan 45 degree upon 1 by root 2. So this equal root 2. So phi equal to tan inverse root 2. So the answer is third one. Now I'm gonna show you why this formula, how this formula comes about. If this is a surface and a ball, any ball comes and collide normally to it, and its speed is e and coefficient of restitution is e. When it return back, its speed will be, velocity of separation will be e into u. One have to keep this thing in your mind. Now this is a surface, and suppose a ball come and strike making an angle theta. So we have, suppose u1 and this is u2 and this is angle theta. So we know tan theta will be equal to u1 upon u2. Now when it return back, it will have two component of velocity. The horizontal component will be the same, but the normal component to the surface will be e u2, just like this. So this angle phi and this angle will be phi. So tan phi will be equal to tan phi will be equal to tan phi will be equal to u1 upon e u2. 1 by e u1 by u2, but we know that u1 by 2 is tan phi, so this equal to 1 by e tan theta. This way we have tan phi equal to tan theta by e. This is very important formula, keep in mind. Now in this problem I1 I2 be the moment of inertia of uniform square plate about axis A P C, this axis, and I2 is moment of inertia about this axis, So we have about this axis, this is I1, and about this axis it is I2. Now we have to find the ratio I1 upon I2. Now one thing I want to tell you, that if I have a rectangular plate, its length is A and width is B, and this is the axis about which moment of inertia is to calculate. It is passing through its center of mass and perpendicular to its plane. Its moment of inertia equal to 1 by 12 m a square plus b square. In case of square a equal to b, we will have I equal to 1 by 6 ma square in case of square. Okay, now if I have a square here, and I'm going to use perpendicular axis theorem. So I have one axis which lies on the plane of the square, and another axis this also line in the plane of the square. Both divide this square into parts. So about this moment of this is y, this is suppose I naught, and this is x, about ix is also I naught, and the this axis which is perpendicular to plane, I mean IZ. So Ix plus Iy equal to Iz. So 2 I naught equal to Iz, which we know that this one, this is just the perpendicular. So this equal to 1 by 6 ma square. So I naught equal to 1 by 12 ma square. I mean 1 by 12 ma square is the moment of inertia of this square plate about any axis which divide in two equal part. Now I am going to see, if I take two axes which also lie on the plane but it are diagonal. So this diagonal and this diagonal, both diagonal lie on the plane, so their sum will be also equal to Iz. So again this is I naught, this is I naught, and their sum equal to Iz. So 2 I naught equal to Iz equal to 1 by 6 ma square. So I naught equal to 1 by 12 ma square. And you know, this is this I naught is about diagonal. So diagonal means I1. So I1 equal to 1 by 12 ma square, and this is this one, this one, it's also 1 by 12 ma square. So this ratio equal to 1. I mean I1 is to I2 equal to 1 is to 1. So this is the answer.